In today's episode of the Procrastination Station, we're going to look at quadratic roots of an imaginary number. But you'll see what I mean, right? So for each of these, write down your solution. So z squared plus 2z plus 5 is equal to 0. Z is obviously going to be minus b plus minus square root of b squared minus 4ac all over 2a. Which is the same as minus 2 plus minus the square root of 4 minus 5. I wonder what's the point of all of this. So if we do that, that's just going to be minus 1 plus minus I over 2. I wonder what's the significance of plus minus I over 2. Oh, I can't see it yet. Let's look at b. Let's look at b. Z squared minus 2z plus 10 is equal to 0. Well, z is going to be 2 plus minus the square root of 4 minus 6 all over 2, which is the same as 2 over 2, 1, plus minus the square root of 2 over 2. Almost as if this plus minus is z and z conjugate. That's the point in all of this. And it's the same thing with z squared, right? If this is the quadratic, then z is just going to be, whatever the answer is, minus 4 plus minus the square root of 16 minus 29 over 2. It's going to be minus 2 plus minus, what's 16 minus 29? I believe it's root, I. There we go. There we go. 13, root 13 over 2, I. Do you understand? So the point I'm trying to make here with these easy examples is if we have a square root, if we have a root to a quadratic and none of it is real, then it has to have a complex conjugate as well. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's use this concept to understand this question. A root for quadratic is 2 plus 3i. The question is what's the other root? Well, if z is equal to 2 minus 3i, then the other solution must be z conjugate, which is 2 minus 3i. Sorry, that's my z conjugate. Okay, cool. That's my other solution. Now, how are we going to find a quadratic out of it? Think about it, people. What was the first method that you were taught how to solve a quadratic? Factorizing, exactly. So we can say that z minus one root, which is 2 plus 3i, and z minus the other root, which is 2 plus 3i. No, one is minus, one is plus. Doesn't matter which one it is. The bottom line is equal to 0. Okay? This is root 1. And this is my second root. So now all we need to do is expand. When we expand, we get a z squared minus z times 2 minus 3i minus z times 2 plus 3i, and then the difference of 2 squares plus 2 minus 3i, 2 plus 3i. It's worth noting that this is a minus because this bracket is equal to 0, yeah, for both of them. So they have to be minus. Alright, anyways. And of course this will equal 0. So now let's expand again. We get z squared minus 2z minus 3iz minus 2z plus, oh, this will be a plus, and then this will be a minus 3iz, and then plus 2 squared minus 9, 4. And now what we can do is collect the like terms. So this is equal to 0. We have a 2z here, a minus 2z here, and we've got a 4 and a minus 9. These will cancel out. And so what we're left with is z squared minus 4z. What's 4 minus 9? Minus 5. That's all equal to 0. So, that is the quadratic when my two roots are z equals 2 plus 3i and z's conjugate is equal to 2 minus 3i. If that doesn't make sense to you, you can join my Discord server and ask me whatever questions you want, anytime you want. Now let's look at this question. Now we're combining what we learned last time and what we learned this time. So, z is equal to 5 over 3 minus I. Given that z forms that, how are we going to find this quadratic? So first things first is let's put z in this form. The z is going to be 5 over 3 minus I times z conjugate, the conjugate of the denominator, which is 3 plus I, which is the same as 5 times 3 plus I, and then that's over 3 squared times plus 1. So what we're left with is a half times 3 plus I. Okay. That means that the other solution for z is going to be a half times 3 minus I. Okay? So those are my two solutions for the quadratic that I'm trying to find. How are we going to find the quadratic? If you want, you can expand it. I don't really want to expand it. So let's first figure out what the quadratic is. So, x minus a half times 3 minus I times x minus a half 3 plus I, that's going to be equal to 0. And so now let's expand the bracket. X squared minus x over 2 3 plus I minus x over 2 3 minus I plus a quarter 3 minus I 3 plus I. Alright, sure. And now we need to expand again. So, x squared minus 3 over 2 x minus xi over 2 minus 3 over 2x minus xi, well, plus xi over 2. And then it's plus a quarter times 3 squared minus I squared, which is just going to be 10. And that's all equal to 0. Okay, so now let's put it up here. What we're left with is x squared. Let's look at our like terms. Minus 3 over 2 minus 3 over 2, so that's just going to be minus 3x. Let's look at our, use a different color. Let's look at our I terms. Oh, look, this is minus, this is plus. They cancel out. And now all we need to worry about is this, which looks like it's 10 over 2. 10 over 4, excuse me. So that's just going to be plus 5 over 2. And that's all equal to 0. So it seems that P is equal to minus 3 and Q is equal to 5 over 2. And those are your final answers. Thank you guys so much for watching. Please drop me an email if you want to get tutored by me and pass your exams. Keep on learning as you have no idea what you're capable of doing.